I am indeed.
Excellent. All right. Well, can we switch over to Hugh's screen?
Yep. Let me just do that.
It's not shared yet. Excellent. I'm actually, this is our decision this year was to try to incorporate, we still have a lot of people joining, so, but my introduction isn't that important, so we'll do that, but give you another minute before you start.
Okay.
Hugh Brock is my co-conspirator on all things MOC and Collaboratory. He heads the Red Hat Collaboratory at Boston University, and he's going to be giving the kickoff colloquium address today for the Collaboratory for this year. He's a research director for all of Red Hat in the office of the CTO, and that's actually become really broad. It sort of started out, I guess, my impression is with BU, and then now it's turned out to be coordinating all the research across universities across the whole world. And the research projects span this enormous breadth from unikernels to field programmable gate arrays, next generation networks and storage technology, and even user experience. Do you actually know anything about user experience, Hugh?
I probably know more about user experience than I do about FPGAs.
Oh, okay. All right. Well, there we go. Before taking on Red Hat's research program, he was in Brno for 3 years, where he led a really large team of people. Everybody I meet says that they worked for Hugh at some point in time on OpenStack management tools. And before that, he's been working in virtualization and cloud. And he now lives in Maine, which is really shocking because he heads a huge group here in Boston. But we get to see him a lot. Anyhow, thank you, Hugh, for offering to give a colloquium address and to teach to my cloud course.
Well, thank you, Aran. I appreciate the introduction and the kind words. I'll just say as we get going here, this is a subject that I could talk about nonstop for a whole day. It's something that I think about a lot, and so I would encourage you, rather than just listening to me run on, please post questions or raise your hand or whatever, and Aran, feel free to interrupt me anytime you want.
I would never do that.
Guck ruhig ohne mich. Ich gucke hier gerade einen Talk. Vielleicht wird es auch langweilig.
Oh, very interesting. My German's not quite that good, but anyway. Let's begin. Let's begin with that. So I'm going to talk today about platforms. And the interesting thing about platforms is that I didn't really understand what a platform was for a long time, and it used to annoy me when our management at Red Hat would talk about about how we were a platform, and why was that important? And I was like, but I write software. I don't build platforms. Nothing stands on what I write. And actually, I was wrong about that. In fact, Red Hat has always been in the platform business. And in fact, I think it is one of the really interesting things about the platform business that Red Hat is in, is that it lends itself very well to open source software, which is, of course, the other part of our story at Red Hat. So I'm going to talk about how what a platform actually is, for the benefit of those of you in Aran's class who may not understand that, and why it's important, why it's an interesting business to be in, why it works well for open source, and what has happened to computing that has made platforms both so different from what they were when I was a young fella, and so much perhaps even more important So when I say platform, what do I mean? In the early days of computing, when you built a computer, there was not the same sort of dividing line between software and hardware that we think of today, because in a lot of cases, the person building the hardware, designing the hardware, was the same person who then wrote the software that ran on the machine. That was the case for quite a long time. It turns out, however, that designing computers from scratch and building them to solve a particular problem for a researcher or later a customer or a business is not actually a very good business model. It doesn't scale well. So if you're a computer company, or you want to be a computer company, what you want to do is build a thing, design a thing that you can sell to a lot of people. Either you sell many copies of that thing, or you sell access to that thing, or whatever. And if you're really good at what you do, you not only build a lot of these things and sell a lot of them, you also enable your customers to use that thing for something useful. And in the case of the history of computing, that thing was doing business. That was where the money was. So the history of computing, and the reason it evolved the way it did, at least in part, was because building something that could be reused over and over again and resold, and that was a good business model.
So Hugh,
yeah,
and just adding context, because one of the things we've talked repeatedly about in the course is how companies that sold platforms like Oracle database, or like some of the message queue services, or like so many of these things where people sold software, or for that matter hardware, like switches, they have been unsuccessful in the cloud world. And so selling your thing to many people that deployed themselves is actually not a great business model today.
Yeah, that's a very interesting point. That's exactly where I'm going.
Okay.
So yeah, I think you're definitely anticipating what I'm going to talk about. So to flesh that out a little bit, and I have a story that I like to tell about platforms. My father-in-law was the president of a sheet music retail business, mail order sheet music retail business, for most of his career. And they were always technically very advanced, partly because my father-in-law is kind of a nerd, and partly because they were as an organization. And so in the late 60s, they began to try to automate their operations. They sent out, because they were in the sheet music business, right? And music teachers order huge numbers of very small, very inexpensive things. So they sent out invoices with many lines for 25 cents each, that were all handwritten or hand typed by clerks in their office, and they were drowning in paperwork. So they decided they had to automate, and they considered two different vendors for this automation story. One of them was IBM, and the other one was Singer. I don't know if any of you know that Singer used to be in the computer business. The Singer, of course, is the sewing machine company. But they had a mini computer offering, I guess, which must have been derived from their loom business or something like that. And long story short, Singer won the contract. And what Singer told my father-in-law was that they would come in to his business, and they would write all of the software that needed to be written in order for this Singer mini computer to do all of their back office operations, produce the invoices, allow the order entry, all of these other things that you would want a computer to do for your business. Well, they set to work, and they were going to do that for free, right? They had a bunch of programmers. They were going to send them in, and the programmers were going to set the machine up for this company, and all for the price of the machine. Well, a year later, they still hadn't run a single order through the machine. They were building the software from scratch, and it didn't work. So they went back to IBM at that point and begged IBM to come fix it. And what their IBM rep said was, we're not going to write the software for you. We're not going to write your business software. What we're going to do is we're going to sell you a System 3, and we're going to sell you a whole bunch of training on how to program it, and we're going to help you build an in-house developer department for your company that can write the software that you will actually use in order to run your business. So they did that. And 6 months later, they had a system that was up and working, and they continued as an IBM customer all the way through the AS400 and RS6000 series and wound up dominating their whole industry. And I am convinced that the reason they did this was because they built an in-house development organization that was able to focus solely on solving their own business problems. Just to give you a concrete example, they had an e-commerce website in the mid-90s before Amazon was even a gleam in Jeff Bezos's eye. So they were very, very technically advanced for a small business, basically, small to medium-sized business. And all of this was because of the relationship with their platform. The platform is what enabled them to be successful, because they could focus on doing what made them special without having to worry about the intricacies of the software itself. And they were enabled to do that work themselves, the special part. So this is a key thing. The businesses need to be able to focus on the thing that is going to differentiate them in the market, and they need to focus hard on that. And they need to bring in smart people to work on those problems without being distracted by the underneath part, which is where we and many other companies. This is not a talk about Red Hat. It's a talk about platforms. Okay, this is where lots of people come in and try to be successful. So let's talk about complexity. Now, what happens as computing develops? Over time, a bunch of different things happen. First of all, computing becomes much more diverse, right? And you have lots and lots of, instead of having single monolithic mainframes, you have lots of mini computers. You even start to have PCs, and you have lots of very large distributed systems. In the 90s, all of these things are running mostly on proprietary operating systems, right? There's no Linux. I mean, there is Linux, but it's not in serious commercial use anywhere. And what happens there is, as computing becomes more and more possible and becomes more and more distributed, it gets harder and harder, not just to debug a closed source system, but to influence the vendors of that closed source system. It becomes a complex vendor ecosystem, right? To do the things that you, the customer, want, to fix the problems that you, the customer, need fixed. So one of the big drivers when an open source operating system, Linux, when the Linux platform comes into, starts to come into general use in the late 90s, is that it's possible for its users, the technically very sophisticated users, to debug and influence the direction of that platform all the way down to obscure kernel bugs that interact with obscure hardware features. Now, the interesting thing about this is that in a way, it is the opposite of what I just said, which is let your developers focus on the things that are important to your business and not worry about all the stuff underneath. The advent of open source in the platform changed that formula to some extent, and made it possible for a platform to be an open thing that developed in a direction that was directly driven by the customers and the people who were using it. So this was a shift in the definition of what a platform is, in a sense. The thing that remains, though, and this is interesting, I think, is that companies who were able to provide Linux as a platform, like us, for example, like SUSE, like the other Linux vendors, companies that were able to provide that did well because even though there were some very technically advanced users of Linux who were perfectly capable of debugging it themselves and influencing the platform upstream themselves, most people still didn't want to do that. They wanted to be able to take advantage of what was happening upstream without necessarily getting engaged with it themselves. And that's where a platform company like us comes in. So that's, you know, that's the first 20 years or whatever. But I know that that may not be all that germane to you right now today, but I think it's important to get that sense of what a platform really is, because it influences where we go now.
So Hugh, sorry.
Yeah.
By the way, I assume you want other people to ask questions. So I'm
Yeah,
just
by all means. Yeah.
trying to get people to be unshy. So you can scratch your own itch, and there's a small community that did that.
Yeah.
I'm not sure I totally believe that. I guess I sort of think about it as the lack of vendor lock-in as being sort of the big thing about open source. I'm wondering if you can contrast that.
I think that is a point, for sure, but my sense is that concerns about lock-in probably take a back seat to concerns about not the ability to find bugs and get them fixed exactly, but concerns about the ability to influence the direction of the platform, right? The neat thing about an open source platform, and to my mind, the really interesting thing about open source, is that it pushes the direction that the development of the thing is going to go out into the open. So, you know, to take a funny sort of an example, we have always at Red Hat, we have always taken the direction for where Linux is going to go from upstream. So where a closed source, a Microsoft, for example, or a Sun back in the day might say, okay, this year we're going to add this set of features to our operating system because we have these 3 customers who say this is what they want, or whatever. Or we surveyed all our customers and they said this is what they want. We don't really do that. And we don't do that partly because we can't, and partly because we don't have to. The direction of Linux comes from upstream Linux, and which is a collaboration between hardware vendors and us and lots of other companies who do Linux stuff, and devices and their device makers and device drivers, and all these sorts of things. So it is an organic thing that moves in a direction that is inherently sort of collaborative. You call that an ecosystem, I guess. But so I think that's actually the most compelling, the most interesting thing about open source. Is that it enables this sort of freewheeling collaboration on what direction the thing is going to go. Right. So fast forward into cloud, right? 2008, AWS is now a real thing. EC2 is a real thing. And this, I guess, not all that coincidentally, was around the time when I really got into the cloud game for real. Cloud is a platform too. And the great thing about cloud as a platform is it's slippery. And what slippery means is that if I'm an application developer and I need to spin up a, some kind of a database spec service, for example, which is what a lot of people were doing in 2008, I could go to Amazon and use my corporate credit card and have something up and running in 5 minutes, right? At that time, I remember, because I had to deal with purchasing a bunch of hardware for Red Hat to host a service, and it took 6 months. And 6 months was pretty fast, actually, right? So we call that friction in the business, and it means that you go from you can avoid your entire purchasing organization, you can avoid the whole hardware vendor and support set of questions, and you just put your service online. It goes very fast. So that, and of course, that is incredibly attractive. It also, zero friction also implies infinite capacity. Or the illusion of infinite capacity anyway. It implies that there is an ecosystem there a set of services that you can also use that become standard. You can look at Amazon S3 as a, you know, the sort of example of that, but there, of course, there's tons of them. It also means now you don't have to worry about your own operations. You don't have to manage hardware upgrades. You don't have to manage firmware upgrades. You don't have, there's a million things that you don't have to do anymore, as compared to owning and maintaining a data center of x86 64 servers or whatever. So what this means is that now the platform has changed again, and it's gone from a sort of very open thing where people had a lot of influence on the development of the platform and what happened, to a much more convenient, but a much less open thing that, not coincidentally, I don't think, looks a lot like a mainframe. I mean, what is a cloud? It's slippery, but it is also effectively a mainframe. It's a big managed compute infrastructure that you don't get to look under the covers of. So there you go. Different platform has now come along. Now, so the downside of all of that slipperiness is that it comes with a cost, and the cost is homogeneity. In 2008, this was not a problem. It didn't matter that your choices of processor were all from two vendors, both of which ran were running x86 64 hardware. It didn't matter that you only really got one choice of computer in 5 different sizes. And the reason it didn't matter is that if the choice you got didn't perform as well as you wanted it to, you could be assured that in another year or two, another set of computers would come out that would be twice as fast. And I'll get to that in a minute, because that's a key part of this whole thing. So a low friction platform requires homogeneity, which means that when you're in the cloud, you can't really do anything super special, right? If you want to use an exotic hardware configuration, you want to use, I don't know, I'm trying to think of a good example from back in the day. Let's say fiber channel attached storage, for example. You couldn't really do that in the cloud at the time, right? And you can't optimize your workload for the specific hardware you're running on. There's a lot of things you can't do. But again, it doesn't matter because the processors keep getting faster, so nobody cares. Thanks to Mr. Dennard from IBM and Mr. Moore of Intel, which and then, so this went on very happily for a long time. Until, recent years, I guess in the last 3 or 4 years, it has become apparent that the regular doubling of chip capacity every couple of years was no longer going to be sustainable. And I mean, we've known that was going to happen for a long time, but it hasn't really started to bite until fairly recently. The thing that made all of those gains in chip speed possible and chip scale possible is Dennard scaling, which holds that one can scale a chip by shrinking the size of the transistors on that chip, thereby increasing their number, while still maintaining roughly the same power density and heat output, other things being equal. So in other words, you can make the transistors smaller, cram more of them on a chip, and it still consumes the same amount of power and gives off the same amount of heat, give or take. And when you get down, this works great until you get down to about 14 nanometers, and then quantum effects start getting in the way, and other material science things break down, and you wind up with power consumption going up to unsustainable levels. So all of a sudden in the mid, 2010s, 2015, 2016, systems engineering starts to get interesting again, and people start building accelerators. The most obvious of which is the GPUs, but now we have lots of them. We have FPGAs, we have ASICs, we have lots and lots of different accelerators that people want to be able to use. Yes.
Before you, just tell me shut up if I'm asking too many questions. But before you go there, Yeah, I'd sort of agree. I mean, that was that huge impact. But before that, what the cloud in some sense did is, because everything was homogeneous and simple, in some sense fungible, right? It enabled this enormous diversity on top of it. So even though it was homogeneous in terms of infrastructure for the most part, this massive diversity of services, like if you look at, you know,
Yes.
AWS, there is thousands and thousands and thousands of services that flourished. Isn't it in part because of that homogeneity?
It's no, that's exactly right. It made it, the homogeneity of the cloud and the low friction environment of the cloud makes it super easy to develop and operate a service on you know, any of the commercial clouds. I keep picking out AWS because they're the big one, but any of them, right? So yes, it is absolutely true that as a platform, the cloud is a really good one because you can really focus right down on exactly the business problem you're trying to solve, and you've got a million different choices of services that will help you find those solutions, right? And that was what happened between 2008 and today, or I would say really a couple of years ago is when things started, the wheels sort of started coming off. Yeah, so you have this great proliferation of services, enormous ecosystem development, but then it started getting difficult to scale things. And the result of that, I was looking at this, it was just playing around with stuff yesterday, and I thought, well, maybe I better go count up these flavors that I keep talking about. And in fact, AWS today has 35 kinds of flavors, you know, compute, storage, whatever, different types, and each of those has 5 or 10 sizes. So you have somewhere between 200 and 350 choices of machine that you need to pick when you design your application. That's not slippery. That is no longer a low friction environment. You have lots of choices, which is great. You have lots of diversity, but it is not any longer easy to just say, oh, I'll just spin that up on AWS, because you have to think too hard about what you're trying to do. And you're, you know, to go get back to Iran's point a minute ago, you're also locked in, right? Now you're really like, if I'm using AWS's storage flavors, it's going to be tough for me to say, I want to take this code and move it to a different cloud, or move it back to my own data center, or whatever. Now, a lot of customers don't care. They're like, we're going to use AWS. It's going to be easy. We don't care if we're stuck with them forever. But there are also a large number of workloads that you really can't actually run in the cloud. And this is where it gets interesting. Compute workloads that have to be tied to their location. And this covers there's all kinds of cases of this. Anything from, I have a huge data set that is next to my particle accelerator and I need to be able to compute on it right there. So scientific and research workloads, to I have some compute in my manufacturing plant. I have an automated manufacturing plant, and I'm not going to depend on some remote infrastructure to operate it. I have a cell tower over here, and I can't depend on some remote infrastructure to operate it because of the speed of light. There's lots and lots of different reasons where this becomes not optimal.
I think you're not quite comparing apples to apples there, though, right? Because in the early days of the internet, the homogeneity was kind of falsely there because everyone was using Java and MySQL, and it really didn't matter what was underneath because there was a really homogeneous environment for doing those two things and showing stuff on a web browser. And if people were trying to do things that were more complicated back then, which some of them were, like VPNs
Sure.
and services, it was really actually not homogeneous at all. You know, if you tried to offer those services on a Microsoft server versus, you know, on a Linux machine, you had zero chance of any of that code working when you moved it. So
Yeah.
it's a combination of the things you can do now being more complex and going farther down in the stack, as well as the way the types of hardware and software have become less homogeneous.
Yeah, no, that's very true. And I think there's a corollary to that I should have mentioned and didn't, which is when I was talking about this early on, I was talking about developer enablement, right? How it's really one of the key parts of being a good platform is enabling developers to do what they need to do with as little headache as possible. And a lot of that is language environments and back-end availability and how you do stuff. And I think there's no question that the development of the cloud benefited from there being a relatively sort of common landscape of things that people wanted to do on the cloud. They wanted to run Java apps with some kind of a database backend and a web server in front. And that is no longer really, not that there aren't a ton of web apps out there, but that's not the focus of computing today. So it changes things a little bit, I guess. Anyway, in the meantime, what happened to operations is the next question, right? So you've had this massive growth in compute infrastructure, right? Giant clouds that make it possible to do lots of things that you could never do before. But of course, at the same time, that means that your operations are also much more complex. I mean, we've had many efforts at Red Hat, several of which I've been part of, at trying just to automate deployment of large-scale distributed systems on clusters of computers. And it's a non-trivial problem to solve. Whereas if you're just spinning up a single machine, or you're spinning up a single machine in the cloud, it's relatively easy. You install some software and off you go. But automating complexity of operations, the scale of operations, demands automation of operations, and that turns out to be really, really difficult. Having said that, it is something that the large cloud vendors have more or less mastered, at least they appear to.
Hugh, I'm curious.
Huh?
I'm actually curious about this question. So they have succeeded tremendously on that. Part of it, the automation they succeeded on, because they had to, but they also were homogeneous. They could pick the infrastructure they were automating on, right? And
Yes.
They could say, oh, you know what, we've settled on this telemetry, we settled on this whatever. When you're trying to automate operations as a company selling to other companies, isn't it a whole different type of thing you're trying to do than they could do for themselves?
Yes. Yeah, it absolutely is. And that actually will be my next point. If your business requires complex IT services, if you're doing if you're trying to model things with machine learning, or do pattern matching, pattern recognition in any kind of scale or whatever, and there's a lot of businesses out there where this is now a required thing, right? You probably can't operate those services in-house. They're too complex. There's not very much ecosystem. Those operating those things should be outside of your business competency, unless you're a very strange organization. And so you sort of have to put it on the cloud. You have no choice. Which brings me to what I promised I would talk about today, which is that it is, in fact, I believe, time for a new kind of platform.
So before you go, can I butt in for a second?
Please do.
Before you go into that, can you expand on why it is so hard to do operations?
Yeah.
Because that's sort of the problem which you're about to solve. So it's better to expand on that problem.
So let's talk about why it's hard. Yeah, absolutely. The hardest thing about it, in my experience, so if you think about Amazon for a minute, The way Amazon keeps its operational costs under control is by trying to keep things as homogeneous as possible within their cloud. So when they, if Amazon buys a new flavor of machines, they buy them in great bulk and they operate all of them exactly the same way. If one of them breaks, they ignore it. It just dies and they keep going on the ones they have left. So in some sense, having great scale makes it easier because you just design your systems so that your machines are all the same, and if one of them dies, it goes away. The problem, of course, though, is that the volume of events, of logs, of management items that you have to deal with as a large infrastructure operator is impossible for even very good human beings to keep up with. So you have to build more and more automation in order to do this operations work, or you simply can't do it. That's not a perfect answer to your question, Larry, and I feel like I should be able to answer it better. I need to think.
I can mention something that I experienced at Harvard was that when we went from the tooling that was built by generations past, that was really for about 200 to 300 servers. When we got to that same space across 2,000 to 3,000 servers, it was starting to really be stretched thin. And then one big HPC refresh, and all of a sudden we realized those tools now don't work at all. And a lot of it is because we had individual points of servers that were serving out some service to our infrastructure, and they now cannot scale to the net volume of requests that are coming in and out.
Yeah.
Now we have to have a whole cluster, right, and build HA services, and you have to rethink how do we do things like Puppet and just a Yum repo and things like that at a scale that's much larger.
Yep.
So I think, Scott, so sorry, just for context, let me give a little more context to the class for a moment.
Hold on. The only last thing I was going to say is that at scale, the signal to noise ratio becomes harder. You get a lot more noise in your system, and it's harder and harder to figure out where things are happening.
So I guess that if I look at it, I mean, you guys are both, or certainly you, Scott, are thinking in the HPC world, but enterprise workloads, it used to be that one administrator would administer 4 or 5 computers, and that was a full-time job. Yeah. Right. HPC was already bizarre because you guys would have one person operating hundreds of computers, right? Now in the cloud, we want one person operating thousands of computers, right? That's just a whole different sort of, and HPC has actually moved with Blue Gene systems like that to one administrator operating thousands of computers as well. And it just, I think it was, I think the scales were just so incredibly different.
Yeah. Yeah, I think that's, you've kind of put your finger on it. I actually have a great story example about that. We were working on an OpenStack deployment a few years back that was, I don't know, 300 or 400 nodes. It was reasonably big, and it kept falling over at midnight every day, and we couldn't figure out why. And we finally realized that the reason it was falling over at midnight was because every machine was requesting a Puppet update at exactly the same time, right? They're all, and you can't change it. That feature is built into Puppet, and the only thing you can do is turn it off. You can't tell it to stagger the times it asks for an update or anything else like that. So this is just like a stupid scale bug, right? But those kinds of bugs grow sort of exponentially as you scale from 100 servers to 1,000 to 10,000.
So we used to have a problem like that with one server in Italy. And, it turned out that it was being turned off at lunchtime by a well-meaning janitor who came through and turned things off because there was no one there. and you never can find that with your pattern searching and tools and all of that. So it happens no matter what, how the hardware evolves. I thought another good point to make, because you aren't talking too much about it, is the economy of how big you are as a purchaser versus how big the market is, right?
Yeah.
So AWS and Facebook, they basically are so big that they can decree that things will be standardized, right? They are the dog and vendors are the tail, whereas most people who are running an academic environment or a commercial environment that's not as huge as that, they're being wagged by somebody else. And somebody comes out with new hardware and you can't buy the old platform anymore, or new software and the old thing is not supported anymore, and you have to respond to that. And you have so many things like that you put together, even in an open source world, that you have to constantly be dealing with that, instead of having a nice, measured plan that you can predict a year into the future about how everything is going to happen, which Facebook and AWS actually do. I've seen them decide they don't like hardware, spend a year making new hardware, deploy it, put it in effect, and then publish papers about how much better this performs, right?
Yeah.
And there's no way that most people can do that.
I think all that's true, but I think one of the big differences in all this is that they have, as you said, the ability to amortize the overhead of engineering, because they're going to do it at a certain scale. But it's sort of fundamentally different to try to build a general purpose system that's intrinsically more complicated, that many people are going to install and operate themselves, versus building a system for yourself to operate, where that's why it's the cloud, I think, it's revolutionized not only the operations of the data center scale and all the computers and all that kind of stuff, but the people deploying applications on top of it could move into agile methodologies, and operate their software just for themselves, rather than having to write software that other people install.
Yeah.
So I sort of think it's the two levels of operations have dramatically changed, have resulted in, both at the application level and at the systems level, one operator being able to, at two different levels, operate thousands of computers.
Mm-hmm. Yeah. No, it's the difference between building a product that you're going to hand to other people, which is hard, versus building an infrastructure that you're going to operate yourself, which is also hard, but not nearly as difficult, because you can at least predict what you're going to do with it.
And that at least somebody smart is going to be doing it. Yeah.
Right.
So I want to make one last comment, and then we should go on. But when I think about Walmart and their operations, not their computer operations, but getting all the trucks to Walmart, shelving everything, talking to every supplier, that seems incredibly complicated, and more complicated than running a large data center. But you're all telling me that nope, running a huge data center is more complicated than Walmart having to deal with sick drivers and all that other stuff. But we can have that discussion later. I think we should move on.
Yeah, no, it's interesting. I might argue that the logistics problem is not necessarily easier, but it's better understood, and it doesn't change as rapidly. I don't know. Anyway, so taking a quick step back. So we're now in a place where people are no longer stopping the operation of their own stuff, because it's easier to hand it out to the cloud. But the cloud is no longer really sufficient for what you want to do with it, for all kinds of reasons. It's not as frictionless as it used to be. I believe that what this means is that we need a new kind of platform. Lots of people believe this, not just me, which doesn't mean it's true, but I believe that we need a new kind of platform that we call an autonomous open hybrid cloud. And I'm going to try to explain to you what I mean by that, because it's tricky. But so your developers still need great tools, and low friction, right? That doesn't go away. Your users, the people who are consuming your service, require operational excellence, and the reason they require that is that they want things to work, right? Nobody cares about operational excellence really, except the person who is counting on a service being available, and then someday it's not. You yourself need an ecosystem where there are lots of services available, because you need to attract people to your service, your your platform. Your customer, though, also needs to be able to write code once and have it run in many places depending on what they're trying to do. Not because you want them to be able to do some kind of fancy arbitrage between, okay, today Amazon's cheaper, so I'm going to go there, but because systems today are more distributed than they were even 5 years ago, and we believe they're going to continue becoming more and more distributed. And you don't want to have to write different code to run on in all of the different places that your application needs to live, right? So you need one application that will run on the edge, or in your data center, or on a public cloud. We think that the solution to this is what we call a hybrid cloud, which means another platform, Kubernetes or something like that, that can sit above more than one cloud and allow your application code to be portable across infrastructures. The point of having something sitting above the clouds is that it can smooth out the friction that comes from all of these different devices that are available, different landscapes, different services, and so on. This is hard. And you will notice that I am glossing over a whole bunch of hard things when I talk about building another abstraction layer on top of multiple clouds. So let me tell you how I think we will do it, or how I think someone will do it. I don't know if it'll be us or not, but I think somebody's going to do it one way or another. You start with the word autonomous. So what does autonomous mean? It means that you have to have workload and infrastructure aware scheduling in your platform. That means that your scheduler needs to understand what's going to be run and put that workload on the optimal infrastructure for it, right? It needs to be able to find the right kind of processor, memory, and storage, and so on, and work with that, optimize that as best it can. This is not a new problem. We've had HPC schedulers doing this kind of thing for many years, but I would contend that because of the heterogeneous hardware problem, it is a more complex problem than we've had to deal with in the past. And we think this will have to be, the process of finding the right place to run a workload will have to be AI driven. You will need to be able to compile your code and build it on the fly, because you're going to have to be able to optimize the code that you write for the accelerators that are available to use. To give you a concrete example, today in RHEL we ship glibc with we ship one glibc, which is built one way with one set of flags. And we build it that way because it is the sort of, how would I say it, least ineffective combination that makes all of our customers less unhappy. Ideally, we would be able to rebuild it depending on what kind of thing it's going to run on, and we would gain huge performance optimizations for each of those different workloads. TensorFlow has the same problem, only much worse. You really have to rebuild TensorFlow depending on what infrastructure you're going to run on, what kind of thing you're doing, and all that. We think all of these things need to be automated and just in time, and that's a huge task. It's hard. We need AI we need dependencies managed by AI. We have a project, an open source project for this called Thoth that my friend Daniel Reek is spearheading. And what it does is look at all of the things that are running out there that are willing to publish their software dependencies, and look at all of the publicly available bug databases, of which there are many, and try to figure out what the best possible stack is for a particular use. And that needs to be improved and so on. So that's managing your dependencies with AI, which also implies, of course, that there will be no more manually built software distributions, which of course is what we do at Red Hat. So that's going to be interesting. I'm not as concerned about that as you might think I would be for various reasons, but there's no question that this is going to change our business. And as I said, all of these things have to become AI driven. We believe that in an open hybrid cloud, you need an ecosystem that is truly open, not managed by a single entity. So in a typical public cloud, you have a set of services you can choose from. There's a large number of them. They're all very well maintained because that's the cloud's business, but they are managed by a single vendor. We think that an open alternative to this will always be better and more appropriate and faster reacting to the demands of customers.
So Hugh,
yeah.
Do you mind if I interrupt for a sec? Sorry.
Please
I just wanted to actually draw for the class something. So last week we had actually invited talk by key developer at Facebook, who was talking about their infrastructure as a service offering internally. And it just want to kind of tie this into what Hugh's talking about now, or the previous point, is, you know, it was okay that at one point you actually kind of, the OS was configured in a standard way, but Facebook doesn't work that way, right? They actually tune the operating system for the applications. And so even though they use containers, for example, to deploy things, they actually go all the way down to tuning each OS, and they get factors of 2 or factors of 4 performance improvement. So we've given up on those large factors by dealing with homogeneous tuning of the operating system, homogeneous hardware. In this world, you know, post Dennard scaling, we can't do that anymore. And it was actually really fascinating because we presented to you, and I thought you'd like this. You know, within 1 week, we talked about Borg, Mesos, Kubernetes, and then Facebook's new infrastructure service. And they're the first one I saw that said, we got to optimize all the way down for the application.
Yeah. Yep. Yep. Yeah. And if we're going to do, you know, it can't be easy for them to do that. And they own all the infrastructure, right?
Well, they own the application, so they tune it to the application.
They tune it to the application. We really, as an industry, if we're going to operate successfully in the open, and this is something I think this is super important and interesting for students in this course. You need to be thinking about how software gets built, run, and managed entirely by AI, because that's the only way we're going to make it efficient at the scale it needs to be efficient.
If you had to predict like when you thought that would take over as the norm, how long do you think it would take to catch on? I'm only asking because like I know when GPUs came out and in computational chemistry and quantum physics and stuff, like we just started porting things, and it's been 20 years now, and now it's becoming normal in research space, but still very few clusters are GPU dominated. So
I think it's a long, hard road, but on the other hand, there is there's such huge pressure, you know. I think we could see major progress in this in the next 5 years. Because I mean I think and certainly Red Hat will be trying to drive it, because I think it's very important for us that these tools come into start being mainstream, you know. But I can't understate how difficult I think it all is. I think it's very hard.
Don't you think, Hugh, I mean, sort of when GPUs first came around, right? I mean, they were popularized for, you know, whatever gaming device stuff like things, but in a way, they didn't have a mass market, right? They really were critical for an HPC kind of use case. But now with machine learning kind of exploding, essentially everything is now HPC. So I sort of think that, Scott, the transformation, you were in a sense talking about transformation happening slower in a world where it was maybe niche is too denigrating, but still nowhere near applying to every business in the world. And today, HPC applies to every business in the world, doesn't it?
Yeah. I mean, every time you pull out your phone and use a Google search, that's what's happening on the back end.
Yeah.
Yeah, I mean, I think I'm just curious, like, as we have these shifts in like technology, it's obvious, like, yeah, this is the future. It's interesting to watch the speed of time it takes to like become mainstream. I would think that it would happen quicker now because it's really common that any kind of modern company is using this kind of infrastructure.
Yep.
So it's not like it's not a niche thing. So it should, I would think, take on faster that operating and using principles of AI around workflow management, problem solving, on the operations side would just be like 5 years from now. I think we're going to see that be mainstream.
I think it has to, I think it has to. Well, just one or two more slides, and then I'll finish up. It sort of goes without saying that the hybrid piece means that you need to be able to place your workload wherever you want to place it, and that means that the person who owns the platform, the company selling the platform, has to be able to make that platform successful on a variety of infrastructures. And that takes us back again to the AI piece, because we know that this is not really something that can be done effectively by hand. And then finally, you keep the cloud piece. The interesting thing about this, people asked me this morning, we say at Red Hat, we want to create an open hybrid cloud. They're like, well, where's the cloud? Well, it isn't, right? We're not going to go into the cloud business at Red Hat. But the experience is that of a cloud. That's what we aim for. We don't want to lose, because cloud is such a fantastic platform, right? We don't want to lose that. We don't want to lose elasticity. We don't want to lose developer velocity. We don't want to lose the fact that things are always up. I mean, when was the last time anybody backed up their computer? Right? I quit doing that years ago. I could throw my laptop out the window at this moment and I would lose nothing. Right? That's phenomenal. And we don't even think about it. And that's because of operational excellence in all of these services that we just depend on. Anyway, and then the last piece is tricky, and I really did want to get to this, and we've only got a minute to talk about it. But the operations piece, operations needs to go into code, and operations needs to go into AI, and it needs to be open, right? If operations stays closed, then those of us who work in open source are going to have a real problem, because the value of operations is increasing, the value of code is decreasing correspondingly. So this open hybrid cloud thing, it needs to happen in the open, and the operational piece also needs to happen there, which is part of the mission that we're trying to serve at Mass Open Cloud, for example. Because if it doesn't, then we're sort of going to be stuck with these giant public clouds, which would be a shame for those of us who like to do things in the open. There's a lot more I could say about that, but I'm up against the end of the time. Do we have any more time for questions?
Yeah. As long as people want, I can hang around for.
I will.
So I'll ask one to get started. When years and years ago, Microsoft seemed like an unassailable monopoly. This closed source operating system and set of application suites sort of dominated the computer industry, and I'd sort of say stifled innovation in some sense. And you know, a number of people, even on this call, were involved in sort of the Linux movement, which actually kind of broke that monopoly, and it took years. I guess depending on how you count it, the Windows monopoly lasted between 15 to 20 years. How long do you think, you know, I guess it's not a monopoly, it's maybe an oligopoly, but how long before how long do you think this is sustained? Do you think that they'll stay public clouds as an oligopoly? Do you think that this kind of a thing will displace it? What's your prognosis?
I don't think it's sustainable. I think over time, well, several things could happen. For one thing, I think that it is likely that there actually will be some kind of government antitrust action, and that they'll some of the things that Google and Amazon do that clearly are actually predatory, they will have to stop doing, and that will make a difference, and broaden things a little more. But even absent that, as I think the sort of pendulum swing toward sort of widely distributed computing is really only getting started, and I think it's hard for a centralized vendor to effectively do distributed computing. So I think that there will be a back and forth there for sure. We'll see, but that's my guess. And the other thing that I think is interesting is if operations becomes automated, if self-driving clusters become the norm rather than the exception, then the incentive to give that to somebody else, to an Amazon or an Azure or whatever, becomes much lower. Because, you know, why would you want to give up control of that if it was easy, right? You only give up the control because it's hard.
Other questions? Well, thank you very much, Hugh. This was great.
Well, you're welcome. It was a pleasure. Thank you all for having me.
And clapping doesn't happen in a virtualized world, but I'll clap.
No. Well, thank you. I would buy you all a drink, but I can't do that either.
This is a student class.
All right. See you later.
Thanks, everybody.